Good evening, everyone, and welcome back to Chemistry Online. So, we're going to look at nature of matter. Nature of matter. Okay, so recall that chemistry is the study of matter, what matter consists of, what its properties are, and how it changes, how matter changes. Matter is anything that has mass and occupies or takes up space. That means that anything that is physically real is matter. The liquids we drink, the gases we breathe, the plastics, the books, even the chair you are sitting on or the floor on which you stand. Those are all matter because they all have mass and they occupy space. Now we are talking about mass. What is mass? When you say something has mass, some people define matter in a wrong way. They say matter is anything that has weight and occupies space. No. If something does not have mass, it won't have a weight. So mass is the most important at that point. So why am I saying so? The mass of an object is the quantity of matter within an object. Let me break it down. Let's say sugar. If you see granulated sugar and then I give you 1 teaspoon of granulated sugar and I ask you form it into cube, and then maybe you have a resource, you have a machine to form it into cube, and you look at the size, then I give you 2 spoonfuls of another sugar and say form that one into cube. You form it into cube and then you compare the 2 cubes of sugar you just formed. What you will observe is that 1 cube is bigger than the other. Technically, what you are seeing is that 1 cube of sugar contains more particles of sugar, so to say. The quantity of sugar in one is more than the other. So that makes the sizes of the 2 cubes of sugar different. So we can say the mass of 1 cube of sugar is different from the mass of the other cube. Indirectly, we are saying the quantity of sugar found in 1 cube of sugar is different from the quantity of the granulated sugar found in the other cube of sugar. So understand now, the mass of an object is a quantity of matter. Remember, matter is anything that has mass and occupies space. So quantity of matter, quantity of these particles of sugar that makes up the whole cube of sugar. Mass of an object is a quantity of matter within an object. Now, this quantity cannot change regardless of location, and even regardless of the gravitational pull. The mass, the quantity cannot change. So I don't know, the best way to describe matter is to use the different kinds of properties that matter has. So we are going to see that. Okay, so physical and chemical properties is what, of course, we'll be considering as properties. You know already that physical properties are characteristics that describe matter physically. It includes some characteristics like density, size, okay, shape, color, okay, the mass, as the size, okay, amount of particles or matter present in it, the mass, even density, hardness, taste, how the thing tastes if you put it in your mouth, the crystalline form, even malleability. All these are physical properties because you can physically describe those properties. And these characteristics can be observed or measured without changing the chemical identity of the substance. Okay, you can observe the color, you can observe the shape, you can even measure the shape and size and all that without actually making any adjustments to the identity of the substance chemically. Whereas chemical properties are characteristics that describe how matter changes its chemical structure. That's how matter changes its chemical composition. Okay, so that means chemical properties will be describing the potential of matter to undergo some chemical reactions, to undergo some chemical changes. Example, let's say hydrogen has the potential to ignite and explode given the right conditions. You're saying that was a chemical property. Hydrogen has the potential to ignite, catch fire, and explode given the right conditions. So that's a chemical property, because the chemical properties describe the potential of matter to undergo some chemical reactions or changes. Okay, so from the example I just gave you see that flammability is the chemical property. Hydrogen having the potential to ignite, that's catch fire and explode. The property I'm looking at technically is flammability. Okay, flammability. That's flammability of hydrogen, the matter now. I'll give you another one. Let's say metals. Generally, they have the chemical property of reacting with acids. That's metals react with acids. Of course, when they do so, they liberate hydrogen gas. But the fact that I'm saying it has the chemical property of reacting with metals, technically I'm saying it has the potential of reacting with metals, because we said that chemical properties describe the potential of matter to undergo some chemical changes. All right, so that's another chemical property. I'm just trying to make sure you know how to differentiate between physical property and chemical property, because I know some people would be thinking, why did I say density, malleability, crystalline form is a physical property? Okay, so now you know. Now, the observation of chemical properties involve a change in the chemical identity of the substance, and this will result in the formation of a new substance which has different physical and chemical properties from the substances that started the reaction. What I'm saying in general is that since we said that chemical properties undergo chemical reactions, then there is this tendency for the chemical identity of the product after the reactant is or takes place. The chemical identity of the product changes, and when it changes, what is the new product? Of course, you're already hearing me say new product. The new thing formed will now have physical and chemical properties that are different from the substances that were used to form the new substance. Take for instance, let me go into the lab. Say I add sodium hydroxide to hydrochloric acid. Just added an acid to a base. Now the starting materials is an acid HCl and a base NaOH. By the time they react, it will form salt. Now this salt is going to be NaCl. Though it takes Na from sodium hydroxide and takes Cl from hydrochloric acid, but what is formed newly, the NaCl, is or has chemical properties and physical properties different from that of the HCl and NaOH. NaOH was a base. HCl was an acid. What is formed is not an acid, it's not a base, it's a salt. New thing entirely. Okay, so that's what happens to chemical changes, or chemical properties, of course. New substances are formed, and these new substances have different chemical properties, or and most times also different physical properties from the material or starting material before the new substance was formed. So in general, I'm saying in physical properties, we can describe these properties physically. But in chemical properties, we are talking about the potential of matter to undergo chemical reactions. All right, good. Now let's look at physical and chemical changes then. Now, a physical change is a change in which the matter's physical appearance is altered, but composition remains the same. You alter the physical appearance, but the composition, what it is made of, still remains the same. That's to say, chemically it's not changed, but physically you've changed it. That means no new substance will be formed because chemically it's still the same thing. So what I'm saying is that in physical changes, no new substance is formed. So because the same element or compound is still present before and after the change. Example, let's say liquid water. Let's say water in liquid form freezes into water in the solid form as ice. Can you tell me that the water in solid form, the ice, is no more water? No, it's still water, but water has changed in state. Physically, it was liquid, but the nature of it physically has been altered, is now solid, no more liquid. But chemically, it is still H2O, water. That's a physical change because only the physical parameters were altered and the composition still remained the same. So physical changes, no new substance is formed. It is still water, but physically changed from liquid to solid. Though it appears changed, but the change is only physical and the composition of the constituent molecules is still the same. All right, that's to say it still has the 11% hydrogen and 89% oxygen by mass in composition. Doesn't change, right? Another point to note in physical changes is that physical changes can easily be reversed. Use that water, for instance. You froze water from liquid to solid. We can easily reverse that. Just heat it, it melts back. So you can easily reverse a physical change. That's one easy way to know that a change is physical. It can easily be reversed. Okay. Other examples of physical changes includes change in the state of matter. It's not just liquid to solid. It could be solid to gas as sublimation. It could be gas to liquid. That's condensation. But all the changes in the state of matter, melting of solids, freezing of liquids, vaporization of liquids, sublimation of solids to vapor, all those are examples of physical changes. Also, dissolution of common salt in water. If you put your table salt in water and dissolve it, stir it till you don't find any trace of the salt in the water again, and it's dissolved completely, that is still a physical change because we can easily reverse that. Just boil the water to dryness. As you're boiling, it's evaporating the water. It cannot evaporate the salt, and at the end of it, the salt stays back inside the kettle or pot or evaporating dish. Also, separation of mixtures by evaporation is a physical change. Now, a chemical change is a change that results in the change in composition of a substance. So in chemical change, there will be a change in composition of that substance that is undergoing the chemical change. And the elements, or maybe the compounds, at the start of the reaction will be rearranged into new products. Okay? So therefore you say chemical change alters the composition of the original matter. Examples of chemical change include burning of wood to ash. You put wood in fire and burn it. You see, it forms something new, and that new thing is called ash. Ash is not the wood, it's a new thing. That's why a new name is given, ash. Now, another way to know that it's a chemical change is you cannot reverse the ash back to wood form. You can't. So that's to say, in chemical changes, chemical changes are not easily reversed. All right, and then new substances are formed. That's the more reason why it cannot be reversed, because something new totally has been formed. Also, rusting of iron. If iron starts rusting, you can reverse the iron back to when it didn't start rusting, or reverse the rust back to the form it was before the hydrated ferrum oxide attacked or came to formation. So rusting of iron is a chemical change. Also, fermentation and decay of substances like leaves. Let's say leaves of mango falls on the ground, and after some time it decays, becomes brown, and then starts becoming soft, and then before you know it decays and enters the soil. Can you return that leaf back to when it was green? No. So that gives you an idea that that's a chemical change, because you cannot easily reverse the reaction. So fermentation, on the other hand, is what you do to preparing fufu. You soak your cassava, and then before you know it starts fermenting, and the alcohol is produced and then removed. That fermentation, you can't reverse it back to how it was before fermentation took place. So fermentation is a chemical process, chemical change, and decay of substances like leaves and carcasses are also chemical changes.